guys, we're going to be looking at another special kind of trinomials called perfect square trinomials. They're very similar to difference of squares, but of course, there is a small difference to them. So, first off, here's an example of a perfect square trinomial. If you take a look on the left side and the right side, you will once again see these perfect squares. 9 is 3 times 3, x squared is x times x, and 25 is 5 times 5. There's a few differences compared to difference of squares though, right? Because this has pluses and it has a positive 30x in the middle, and that's not a perfect square. But we're going to see how this plays out when we go ahead and just do our typical factoring of a trinomial, right? So the first thing I'm going to do is get my x. I'm going to do 9 times 25 to get the number on the top, which is 225, and then I'll put 30 at the bottom. And we're going to skip ahead to figure out what the two magic numbers are to multiply to get 225 and add to get 30. But take a look what they are, guys. 15 and 15. A little bit suspicious, right? 15 and 15. Let's take a look at this. I'm going to do 9x squared. I'm going to take my 30x and turn that into 15x and 15x. Okay, now that I have all of this right here, I'm going to go ahead and do the grouping method this time. The perfect square of 9 and 15 is 3, and they both have an x, so it'll be 3x. 9x squared, 9 divided by 3 is 3, and they have a single x left. 15x, it's going to lose its x, and then 9 divided by 3 is 5. So we did the first part, which means the second part should also result in 3x plus 5. So let's try that out. 15 and 25 can both be divided by 5, and only one of them has an x, so we'll leave it at that. 15 divided by 5 is 3x. And then 25 divided by 5 is, boom, look at that, guys. We have the exact same 3x plus 5, 3x plus 5. Now I can add up the 3x plus 5 right here, and I'll get 3x plus 5 times 3x plus 5. But aren't these the same? Couldn't I make that into 3x plus 5 squared? Yeah. So look what we finally ended with, guys. This is called a perfect square trinomial, which turned into a perfect square of a binomial. So now it would be great, guys, once again, if we could just take a shortcut and cut through all this mess and get our answer, right? So once again, I'm going to attempt to show you a shortcut that'll make your life a little bit easier for these perfect square trinomials. So here's a shortcut right here. First off, look at this. 3x, we have a 3x over here. And 3x times 3x, isn't that 9x squared? Meanwhile, the 25 and the 5 times 5 is 25. In fact, if I square root the end ones, I'll get what we start with and what we end with, right? But the question is, where does this 30x come into play? Well, if you think about this for a second, guys, if I take the 3x and this 5, and I get 15x, isn't that really close to 30x? In fact, if I just times it by 2, I'll get 30x. So the shortcut here is if I square root the perfect squares on the end, multiply them, and then multiply them by 2, and I get what's in the middle, I could just, boom, immediately just get the answer right there. Square root, and separate by addition or subtraction, depending on what we have right here. It always has to have a plus 25 or a plus perfect square on the end, but this right here in the middle could be a positive or a negative, and that determines if this is a positive or a negative. So if you don't fully understand what I'm talking about, let's go ahead and look at a few examples right here. This one doesn't look too complicated, but let's see if this is a perfect square. I'm going to square root x squared. That becomes an x. Square root of 16. That is 4 times 4, so it's 4. Now what if I take x times 4 times 2? That ends up being 8x, right? Look at that. That's right in the middle. So our answer is just going to be, if there's a negative right here, x minus 4 squared. Do you see how, just by recognizing this, guys, we can instantly get the answer? Let's go ahead and do example 2. Let's look at something that's a bit more complicated. Look how crazy this looks, right? Look how big these numbers are. But we can take our shortcuts. And I'm just going to square root what's on the ends. 49x squared becomes, well, square root of 49 is 7 times 7. So that's 7x. And then the square root of 100 is 10. And if I take 7x times 10 and multiply that by 2, I do get 140x. So because everything checks out, I could just take these square roots right here and do 7x minus 10 squared. And that's a nice little shortcut when we talk about perfect square trinomials. It's a little bit hard to figure out on the first go, guys, but I have faith that if you guys do a few practice problems, you'll get this. If you have any questions, guys, make sure to email me or ask me in class. Otherwise, you have a great day.